All right, so yesterday we multiplied and actually we didn't divide, we just multiplied radicals. So some people think that adding and subtracting is more difficult. I would just say that it's different. And being that it's different, you just need to learn the rules. Most of the mistakes that I would say don't come from complexity. They come from just mixing up the rules with multiplying. So let's compare and contrast first. Just like with multiplying, we have to have the same index. You saw that yesterday. What's an index? $5, please. What's an index? The thingy with the thing and the thing. So use your words. Well, no, it's not. It's not a radican, but that's coming up. What's an index? We talked about it the past 2 classes. No. Come on, Nico, you can do it, buddy. What's an index? Soha? You were doing well yesterday. Go ahead, Lana. Yeah, you can say better than that, yeah.
We don't know.
You speak for everyone. You've been elected the representative of the room. Soho, you want to give it a shot? No. Taiwan? You did tell me that. No, we're not. It's thinking time. Rosalind, do you know what an index is? Do you know what a hoodie is? The index is the little number that goes on the top left of the radical sign. You don't really have to worry about it because in this class we only deal with it really with one type of index, which is with a square root. And what's the index on a square root? On a square root, you don't see an index. The index is that's what Emma was just drawing. It's the little number that goes there. You don't see one on a square root. So because what's the number that's there? A 2. But this is just free knowledge. Just like with multiplying, in order to add and subtract radicals, they have to have the same index. But again, you guys won't have to worry about that because for you, there's always going to be a 2 there, an invisible 2. More free knowledge for multiplying and dividing. If the indexes were to be different, there is a way to fix it. You won't have to worry about it, but there is a way to make them the same. Adding and subtracting, there isn't. And when you're adding and subtracting, if the indexes aren't the same, you just can't add or subtract. But now, in addition to that, something that wasn't the case yesterday, we also have to have the same radicand. And since there was a little bit of a gray area yesterday where these lessons got kind of muddled together, you can use context to take an educated guess as to what a radicand would be. Definitely not the outside number. The inside number, yeah. So now the number, in order to add and subtract, the number underneath the radical has to be the same. Multiplying? No. Adding and subtracting? Yes. That's the big difference. Now, if the radicands are not the same, yes, ma'am. Well, no, see, the outside number is called the coefficient. That's what we're going to get to here in blue. The index is just like, it's a little number that's supposed to be attached to the radical. Emma even kind of said it's little, like an exponent is little. You write a little teeny weeny little number there. You just don't see it on a square root because when the index is 2, you don't have to write it. Now, see, if the indexes were to not be the same, I just told you you can't fix that. But if the radicands are not the same, you might be able to fix it. You might be able to make a mistake. And you can do that by trying to simplify the radicals, which we did 2 classes ago when we weren't wearing pink hoodies in class, even though our ears are cold. Just so once you've decided that you're ready to go ahead and add and subtract, here's another slight difference. When it comes time to add and subtract, you're only going to add and subtract the coefficients. If you want to use the same terminology we did yesterday, we're only going to add and subtract the outside numbers. This is where studying comes in. And practice and practice and practice so we don't make silly mistakes. Multiplying and dividing, outside with outside, inside with inside. Even though you guys aren't going to divide, you're only going to multiply. Well, now with adding and subtracting, we only add the outsides, and then the radical, which we just said was the inside, will stay the same. Yes. Do I only what? It depends. I got in this case I have 4 shots at it, so I wear this until I find a class that I felt went well, and then I'll post that class. Normally you guys are gonna see it because my first period doesn't have a lot of good days. Today they weren't bad. I wouldn't mind using that class, but I'm gonna see this one a little better. Cool. It makes me look cool, doesn't it? All right, so sorry about the quality of the printout. Well, because these problems I already had them on a file that was on a different program, and it doesn't let me carry it over into this one that I have to do it with a weird way that I can't edit it and stuff. So what's nice about this one? I want to add. What do we like? The radicands are the same, so we're ready to add. When it comes time to add, what numbers get added? Just the outside. What is 6 plus 9? Think of it this way. In many cases, radicals behave like variables. So theoretically, hypothetically, if I were to add 6x plus 9x, what would you tell me? 15x. Well, yeah, here I'm still going to get the 15, but just instead of x's, what's there in the place of the x is the square root of 11. And that doesn't change. But there was a second step. You want to make sure that that radical is in simplest radical form. How do I know that I cannot simplify square root of 11? It's prime. Good. P rhyme. And what? Okay. If you can't see it, just darken it in a bit. What do we like about this one? The radicands are the same again. Now, but this would cause a lot of silly mistakes, so believe it or not. Even if you think you know what you're doing, a lot of people make mistakes here. So see if you can take a guess. Why do you think this could cause some issues for people? Well, that's the thing. There is a number on the outside, but they forget. People forget that there's a 1 here. So remember that adding and subtracting only occurs on the outside. So I can usually get people to remember, hey, the square root of 3 is going to stay the same. But if you don't remember that there's a 1 out there, the subtraction is going to be wrong. It isn't 0 minus 5. It's 1 minus 5. Yes. Anytime you don't see a number outside of a radical, there's a 1. But wait, Mr. Romero, didn't you just say there was a 2? I know you just said that there was a 2. No, the 2 is, the index is like a little number there. If you were to write it, the little 2 would be there. It just tells you what type of radical. In this case, it's a square root. If in the past you've had some experience with radicals, depending on what teacher you had, maybe you got into different types of radicals. You might have seen a cube root. Has anybody ever seen a cube root before? Some calculators have a cube root button. Nah. Cube root. Raíz cúbico. Exactly. Uh-oh. I give up. Put a 1. When all else fails, put a 1. Yeah, what's wrong with this one? The radicants for the first time are not the same. So, but before you just give up and wave the white flag, what the notes told you to do, it was to simplify the radicals. Xavier always finds a friend no matter where he sits. So try talking 0 times and just listening. And then if you have a question, ask me. Can I do anything with a 3? No. Why not? It's prime. But the 12 I can maybe simplify. So when I simplify, this is what we did 2 classes ago. So we get 5 square root of 3 minus square root of 2 times 2 times 3. Isaac, can I bring anything out? Prime, you said prime? Oh. Soha, can I bring something out? Yeah, I'm gonna bring out a 2. And probably like either just as important or maybe even more important than what you're bringing out is what you're leaving on the inside, because before the radicals were not the same and now they are. No, you wait. What's 5 square root of 3 minus 2 square root of 3? 3. Remember that the square root of 3 stays the same. Oh no, he didn't. I'm trying my best, okay? Thanks, Hope. Hope, why aren't you in the band? Jason wants to play drums, but he says he's not allowed in the band. Percussion. So. Well, yeah, he wants to be part of the band, but he says he's been blacklisted. The bad boy. His beats are just way too risque. All right, why don't you guys do this one? Raise your hand when you got it. Jiminy Crickets. Xavier wants to play percussion too. No. Nico, which email are you planning on using for? Because I have 2 different ones.
I couldn't get in that email, so I had to make another one.
So which one do you want to use? It doesn't matter for Delta. You want to use Walnick? Okay. No. Soha, is that a real email? The one that you have on Delta Math? Because it has to be something that you're gonna remember. That doesn't even make sense. W. DeFerg? Oh. So you're not gonna be able to remember that, right? So should I delete it so then you can come up with another one? Okay. Yeah. Is this a prime number? 9 is not prime. Guys give up?
No.
Okay. Soha, you got it? Finish Taiwan, what'd you get? Sounds about right. Did you get the same thing, Emma? Who do you think got it first, him or you? All right, let's see how the Wonder Twins got it. Can we agree that the radicans are not the same? Yeah, so before we give up, let's see if we can make them the same. Can the 8 be simplified? Yeah, so let's do so. Can the 72 be simplified? C. You go down 3. So even if your tree doesn't look exactly like mine, we have to get the same fruit. Yeah, the same prime numbers. So 5 square root of 2 times 2 times 2 plus 2 square root of 2 times 2 times 2 times 3 times 3. What can I bring out of the first radical? A 2. What can I bring out of the second radical? 2 and 3. So 5 times 2 on the outside with the square root of 2 left, plus 2 times 2 times 3. Wait, but Mr. Romero, why'd you bring out 2 2's? I didn't bring out 2 2's, Xavier. There was already a 2 on the outside. Xavier, the next stop is going to be Xavier Island. It's going to be all by yourself. Well, that's true, yes. You're not doing much other than having conversations. You're right. You're not facing the front of the room. You're right. I'm wrong. Today when I first got to school, it was like, man, you know what? I really want to just pick on Xavier for no reason. Even though he's doing everything he's supposed to be doing. That's what entertains me, is picking on 14-year-olds. So, especially ones who are innocent and nothing wrong. 5 times 2 is 10. Square root of 2. 2 times 2 times 3 is 12. Square root of 2. And when you look at that, through sorcery, we were able to make the radicals the same. Jocelyn, is that worried face? Which part don't you understand? Okay, well, I already have a 5 on the outside, and for every pair, for every pareja, you can bring it out once. The 2 that's left over stays inside. Here, I already had a 2 on the outside. I brought out a 2 because there was a pair. I brought out a 3. The 2 stayed on the inside. So once you figure out who's coming and who's going, you multiply. What is 5 times 2? 10. What is 2 times 2 times 3? 12. And then the important part is that now what's on the inside matches. At the beginning it didn't match. Now it does. So now we can add. I only add the 10 and the 12, which gives me 22. Square root of 2. Taiwan wins. Boys rule, girls rule. Well, it's your fault. Everything is Emma's fault. That's problem for Elsie. Any questions? Okay, so then we're gonna take advantage then. And even though I don't have a card today, we will have a card. Oh, do you still need this? Okay. We'll have a card on Friday, but you have plenty of space on that paper. Let's just do an assortment of problems from your assignment for this week, which is considerably shorter. You only have 3 skills that we're working on. I already did some from simplifying radicals the other day, so let's work on some of the other 2. So that even if you did poorly last week, because of course the assignment was way too long, this week it's going to be worth the same, so you can improve your grade. Here we're being asked to add. Are the radicals the same? So let's make them the same. Can the 10 be simplified? Well, you can put it into a tree, but 10 is just 2 times 5. There's no pairs. So that first radical is going to stay the same. Can the 160 be simplified?
Yes.
Of course it can. I'll do this first one, and then after that, it's just going to be you guys. So I win. Hope stop flirting. There's a time and place for that. Now is not the time, nor the place, Hope. The more you get used to simplifying these radicals, like if you really have a good grasp on what we're doing, I don't mind if you start picking your pairs straight from the tree. So like if I already know that this is gonna my prime numbers that are on the board right now are 5 2s and a 5. So you could already start pairing them up here if you just want to say. It's up to you. It happens. Okay, we already know that this -6 for root of 10 is gonna stay the same. What's gonna come out of the 160? 2 times 2, which is gonna be 4. And again, if you want to kind of consolidate these steps, just because you feel comfortable with them, that's fine. I usually try to go a little bit slower at the beginning, and then we can pick things up. And then Nico, what stays on the inside?
The answer.
Nicholas.
Yeah, I guess the 5, right?
Just a 5 only?
Guessing.
Yes, wrong. 2 times 5 is, which works out great because now we have matching radicals. And then Elsie says that -6 plus 4 is -2 equals the square root of 10 to 6. And when Elsie speaks, people listen. So we get -2 square root 10, submit, and then the children rejoice because they got the little check mark. I believe it's 30. In 1 week, 30?
Wait, is it due Sunday?
You have to like binge watch episodes of The Bachelor.
Yeah, I watched that. I want to. Wait, what's his name? You watched it?
Okay, you guys do this one. Raise your hand when you got it. That says square root of 6 plus 3 square root of 96. Square root of 6 plus 3 square root of 96. Yeah, I see you squinting. I feel like, would you like to sit closer? You need glasses? You lost them. How can you find them? You should do that. It's an idea whose time has come. Don't worry about it. She said the same thing about me all the time. You just learn to roll with the punches. Not really. Mm. You know what else could be good? Adding radicals. You got it? Where's your calculator? 48. You want me to be your calculator for you? I think you should just get it. I like a calculator. What'd you get? You got 12 square root of 6. Uh,
Oh no, 13 square root.
that might work out. Let's see. The nice thing about these is you get feedback. So he thinks it's 13. Now you guys will have more than one shot at this if you get it wrong, but for me it only gives me one. But I trust Jason, so we're gonna. This is a little bit. Look, I'm still learning this. This is the first time I use this site, but from what I can gather, um, so like I pick how many problems come from each section, right? So since this is a short one, I picked there's 3 skills, so I picked 10 from each. So like, all right, so like here's a problem, right? So let's say you get it wrong. On Khan Academy, it would stay wrong. But this one here, I give you 2 more chances. So if on any of those chances you get it right, it's just gonna mark it right. But it's not gonna give you a hint like Khan Academy would. Um, Now, if you get it wrong, okay, yeah, it'll mark it off. But then like later on, you can just keep on doing extra problems to make up for it. And the goal is to eventually get it up to 10 out of 10. So like let's say you've gotten 6 right, but then you get one wrong, it's gonna go back down to 5. But then if you just keep on doing extra problems, eventually once you get to 10 correct, then that's good. If I would have assigned 5 problems, then you want to get to 5 correct, and then just stop. So you said 13 square root of 6. All right, let's see. Show me 13 square root of. Yeah. All right, so let's work this out because they have a little bit of a weird way. You're probably not gonna understand their way of working it out. So the 6, obviously 6 and 96 are different. You can put 6 into a tree, but you only get 2 and 3. There's no pairs, so that has to stay the same. But then Jocelyn 96, Lana is the 2 and 48. Calculate yourself if you have them. 24, 12, 6. Oops. So regardless of how your tree looks, you should end up with 5 2s and a 3. So I can bring out 2 2s. So we got this square root of 6 first that I couldn't change. But then I brought out a 12. And on the inside stayed 2 times 3, which is 6. But then, wait, I'm sorry. Oops. Yeah, I did it wrong. Sorry. I forgot. I'm sorry. I brought out 4, but there was a 3 there already. So 12. Yeah, 3 times 4 is 12. this is a mistake that even Jason made first. He just put 12 square root of 6 because he forgot there's a 1 in front. What is 12 plus 1?
Whoa.
You already know. Facts. Whoa. No me gusta, no me gusta. It was, I said a derogatory word about you. No, I'm just kidding. It just means that you don't like it. No me gusta means I do not like it. You got it already, Taiwan? No. Show Emma what's up. He ain't scared of no big numbers. Don't guess. Guessing is bad for you. Yeah, so it says 4 square root of 160 plus 2 square root of 40. No doubt. Go, go, go. Go, go, go. You got hurt in JROTC?
Yeah.
Are you okay?
It's not.
Gen X? Genetics. Oh. Go, Rosalind. You already got it, J Money? Go. You said 20 square root of 10. Yeah, that sounds about right. But let's see. Board, show me 20 square root of 10. Boom. So let's see how we got that. So I got 2 trees to do here, though. 160. I was doing these examples last period also, but it seems like this site loves to use that 160. You're gonna probably see that 160 a lot. So that's a tree there for 160, and then the 40. Looks like that. So when we go and pick the fruit, we got a 2 and a 2, and then here's just a 2. Jonathan.
Yes.
The first term already had a 4 on the outside, the one with the 160. And now we're bringing out 2 2s, which is 2 times 2 is 4. So what's 4 times 4? 16, good. And then we're left with a 2 and a 5, which is 10. 2 times 5 is 10. The second term already had a 2 on the outside. That's going to be joined by another 2. 2 times 2 is 12, as the cool kids say. And then finally 2 times 5 is 10. So then when we add, it's only the 16 and the 4, which is 20. Need the square root. Sarah, any questions? You have a question, Emma? No. You have my blessing. Yes.
So you multiply 5 times 2 and the other 5 times 2.
The whole purpose of the tree is to figure out what's going to come out of the radical and what's going to stay inside. Once you've figured out what's outside and what's inside, now you just multiply. So this 2 and 5 didn't have any pair, didn't have a partner, so they stayed on the on the inside, and that's what became that's what became those 10s that are on the inside. On the outside, the ones that did have pairs, I have this is a 2, For every pair on the outside, it comes out 1. So there's a 2 and there's a 2. Those 2's joined the 4 that was already out there. So what is 4 times 2 times 2?
Hmm.
16. On the 40, a 2 came out to join a 2 that was already there. What's 2 times 2? And then once you have that, then you just add as long as the insides match. Let me do one more from this skill, and then we'll move on to the other skill, and then we can live happily ever after, because we're gonna get 100 on the homework this week. You're at 28. 5 square root of 28 plus square root of 7. Oh, could you already pack up? Why? Why? You still have problems with it. There's learning going on. Huh? This, what do you mean? That's exactly what we did today. Yes, Emma. Yeah. Take that, Taiwan. Can I do anything with the 28? Yes. Can I do anything with a 7? No, why not? It's prime. So, Jocelyn has a hoodie, but is not wearing it, like Froseline. I'm bringing out a 2, but there was already a 5 on the outside. What's 5 times 2? 10. What's left on the inside is poor little 7 who had nobody to play with, and he just ran home. Then plus just square root of 7. You can't forget there's a 1 outside here. So magic board of wonder, show me 11 square root of 7. Yeah. Totally do. And then one more, which is kind of similar, but people don't like these because there's words involved, and we don't like words. No me gusta. Find the product of 3 square root of 5 and 4 square root of 5 in simplest form, and then determine if it's rational or irrational. What does the word product mean? Multiply. So I have 3 square root of 5 times 4 square root of 5. And the radicals are the same, but remember, for multiplication, the radicals don't need to be the same, so I don't even care. And what we learned yesterday was inside with inside and outside with outside. And if you look on the outside, what's on the outside? On the outside, we have a 3 and a 4, which multiplies to give 12. And on the inside, you could say that 5 times 5 is 25, or if you learned something yesterday, what's the shortcut I told you? If you are lucky enough to multiply the same radical with itself, just the number on the inside with no square root. What is 12 times 5? It is 60. So that's the first part. The result here is just going to be 60. But then now come more words, more evil words. They want to know whether this number is rational or irrational. The easiest way I can describe this to you is, did the square root stick around? If the square root made it to the end, it's irrational. It is not rational. No more square roots, rational. So this is obviously going to be racional. Because it can't ratio is a fraction. If I wanted to write 60 as a fraction, how would I do it? Not over 100, no, over 1. And then as a decimal, it does terminate. It stops. It doesn't go on forever. If the square root would still be there, it's because it goes on forever. So look, long story short, if you're going to answer rational, it's can and does. If you're going to answer irrational, it's cannot and does not. Here, let's do another one. Oh no, they flipped the script on us. Now what it says sum. What does sum mean? Adding, which is what we've just been working on. Are the radicals the same? No, but when we go to simplify them, 11 is prime, but then here's another word we haven't used much. 16 is perfect. If you want to do a tree with 16, you can. You just don't have to. Because what's the square root of 16? 4. Yeah, it's not 8, it's 4. So the 3 square root of 11 just drops. The 5 drops, but the 16 just became a 4. Not a square root of 4, just a 4. 5 times 4 is 20, plus 3 square root of 11. So I was able to simplify, but I will not be able to add. Please do not write 23 square root of 11. Why can't I add those?
Because they're not.
Well, they're not like. One of them has a radical, the other one does not. Or you could even now, using these words, say that one term is rational and one is irrational. Rational numbers cannot be added with irrational numbers. So for the result, I would write 20 plus 3 square root of 11. Did the radical stay to the end? So this is irrational. And when it's irrational, I told you cannot. Hope you're paying attention for when you do your assignment. I can still do a couple more before we leave. Yeah. How did I get the what? Well, the 5 was already there. The 4 I got from square root of 16. What's the square root of 16? Okay, this one says product. Product is multiplication. 4 square root of 6 times 5 square root of 2. So here the radicals don't match, but that's fine. It's multiplication. On the outside, what is 5 times 4? 5 times 4 is 20. On the inside, 6 and 2 is 12. Am I done? No, because that 12 maybe could be simplified. And it can. I can bring out an extra 2. Jocelyn, if I bring out an extra 2 and I already have a 20 on the outside, what's 2 times 20? 22? No, it's not 22. 40. Thanks, Xavier. Welcome back. So my result is 40 square root of 3. Is this rational or irrational? Irrational, cannot, does not. For sure. Sorry, I want to keep on doing them until we get another adding one. So we got time. Product here. 5 square root of 24 times square root of 6. Here's where we get confused. Do the radicals need to be the same when they're multiplying? No. It's just outside with outside, inside with inside. 5 times 1 is 5. 24 times 6 is 144. Now, if you're clever about this, yes, I can obviously simplify 144. And yes, you can do a tree, but again, if you're follow protocol. What did I always advise you to try first? Yes, I mean, some people can do it in their head, but if you can't do it in your head, use the calculator that you were blessed with. What's the square root of 144? So Rosalind, the 5 was there. Square root of 144 is 12. 5 times 12 is 60. So I write 60. This is rational, and if it's rational, it can and does. Check mark. We like check marks. Let's see, is going to give me an eye. Okay, here we go. Last one. Oh, no, because I said I wanted to get another adding one. Here's another adding one. 5 square root of 16 plus 4 square root of 9. They're obviously not the same, so the radicals cannot be added, but they can't. Not only can they be simplified, they're also perfect. What's the square root of 16? 4. So this is 5 times 4, just like it was on the other one. What's the square root of 9? 3. So this is just 20 plus 12, which is 32. It's 32 is rational because there's no more square root. So it can and does.